Hi everyone. Today we'll cover two basic concepts in finance and apply them to Excel. One being the present value and one being the net present value. And we'll see how these formulas work in Excel. So this is helpful if you are currently a student in finance or any other field and you want to know how to apply this to real life scenarios in Excel. This is kind of what you would be doing at work. Or if you're a professional and you're just beginning your financial modeling career and you're going to need these. They're kind of the bare minimum. Alright, let's begin first by getting a discount rate. And let's say our discount rate is 5%. Doesn't really matter. You can use whatever you want. And here we'll get our period. So we'll do years. Just so we can use a discount rate that's annual. And here we'll have our cash flow. And here we'll have our present value. So let's say we do 5-year forecast. And let's say the cash flow we receive is $50. $50 annually. So to get the present value of these cash flows at the end of the year, we'll simply say the cash flow divided by 1 plus the discounting interest rate. And in Excel, we'll click F4. That's to fix the discount rate. So when we drag down the formula, it doesn't jump anywhere. And then we'll make that to the power of the year, because that's how many periods we want to discount it back. And then we'll just double bracket this, drag it down. And so these are your present values here at the current time, or time 0. And to find the net present value or the present value of these cash flows, we have 3 methods at our disposal. So one will be summation, the other one will be NPV formula, and lastly we'll have the PV formula. We'll just make these a different color so you can see as a solution. So summation, basically just a sum formula. And just sum these cash flows. The reason we could just sum them is because we already discounted the $50 every year to the present value. So we could just sum all the present values. Our next option is the NPV formula. That just requires the rate. And then, again, just the cash flows, but this time we want the undiscounted cash flows. So the $50 every year, because the NPV formula will discount it on its own. So you can see we get the same results. And then the PV formula, which we need the rate for. The number of payments, which is 5 years, so you can either type in 5 or just highlight the 5th year. The payment, which will make negative, because if the payment is negative, then our present value will be positive in Excel. And then we could just say the payment is 50. Future value, we could just say 0, because we're not interested in the situation. And then we could say that this is the end of the period, since that's what we've been discounting. You also have the option of saying it's at the beginning of the period. And you can see here that we get the same solution under all 3 methods. So that brings the question of what's the difference between the PV and the NPV formulas in Excel. We can clearly observe that if we just copy this down. And let's say we change our cash flows. Our first year will remain 60, then we'll have 50, 60, 70, 100, and 120, or any other arbitrary cash flows. You'll see that the summation and the NPV formulas will still match, but our present value will now change. And the reason for that is the way the present value formula is structured. Essentially, it's using a single payment as its cash flow, so it can't account for 5 different cash flows. So in this scenario, we would get rid of the present value formula, and we can conclude then that the NPV formula should be used every time when there's different cash flows. When we have a consistent cash flow, we can use the present value formula, but it's a good habit to just use the NPV formula in case the cash flows do change and you don't notice. So this is it for today's video. Leave any comments if you have any questions. Like, subscribe, and I'll be making many more of these modeling videos and many others. Thank you.